saying that let's do the coding part and we'll understand here. So we have given ages, we have given, then we have given node n1 given, then we have given node 2 we have given, right? So what we will do first, we'll create two distances, right, from a and b, right? So let's suppose I'm giving integer, right, and this is our array, and I'm saying distance 1 2, you can say 1 or 2. I'll give one distance 1 for the node a, right? Let's so this is our node 1, distance from node 1, distance from node 1, right? And this is our equal to new, and we'll say integer, and we'll pass the size. So size we can get from what is this dot its length, yeah, this one. Similarly, we'll calculate another one, and this is we will put here, and we'll give the distance from node 2, and this is nothing but s, right? So we have created two things, two distances we have created. Now what we should do, there is a arrays class that will have arrays dot fill. Arrays dot fill is a method, and we will pass distance. We have our distance. Oh, it is not coming. We have distance, and then we will pass the default value, right? So I'll put the maximum value into it, right? So what we have, math dot max is a value, maximum value, sorry, maximum value is what, integer value, right? Integer have maximum value, integer dot max value will pass, see this one, we have passed this one. Similarly we'll pass what, let me reduce the space, leave the space, this is about 2. So we have taken what, distance 1 and distance 2, we have updated its default value, that we have taken max, right? We have to find the minimum, right? That's why we are giving max value, right? Now we'll call BFS and we will get the minimum distances, right? So we'll DFS for finding the minimum distance, right? We'll call this one, and we'll get we'll traverse all its you can say its distances, right? We'll have to get the all the distances that we have to find. So we have we are finding, we will call DFS for finding the not minimum distances, distances from each node, right? Distances from nodes, you can say. So how we'll do that, we'll create one DFS utility method, and this method will take what, we have to pass node 1 node 2. Let's see, this is our node, right? And this is our edges, right? We have edges we will pass, then we should pass what, starting node, right? What is the starting node? We have a starting node is node 1, then we will pass what, distance. In the distance we will pass letter, right? So we'll pass edge we have option, node we have pass, right? And then we should pass its length also, right? So it will be easy, or if you not pass it, it's okay. Edge we have, node we have, then we will pass the distance, yeah, three thing will pass, okay? Node will pass, its distance we will pass, and edge we will pass, okay? So this is the starting node we have, from where we will do the calculation, right? And this is the array we have that we will pass. So these things we have done. Now after this is for node 1. Similarly we'll calculate for node 2. So we'll pass node 2 here, and here we will update, right? That's all. Now we have created this one, this method will create it, right? Now what happened, now we will do we'll create this DFS method. So let's see, this method will do what, we'll implement this one, is it fine? Or let's do it, we have DFS method, utility method, and this is void method, and we'll pass what, we will have these two we have already, that we will pass, and then we will pass our distance, right? Three things we will pass is, this is our nothing but what, the node from where we will start. So we'll say starting node, and this is the distance we have from the node. Okay, so I'll take distance, that's all. Now what we should do here, uh, first of all we will take a queue, right? And queue will take integer, and this will take what, this is nothing but our queue, and this is a new array list, like this. Okay, or better we say linked list, right? That is good, linked list. We have taken array, we have taken a queue, and we will put all the node from starting to end, right? So what we have to do, we will say this queue dot will do add, will pass our what, starting node, will pass our starting, this is our starting node, right? So we have passed our starting node. Now we will calculate its distance, right? So now we have distance, the distance of the starting node, we will say itself have a 0, right? Distance from itself, distance from itself, like this. Okay, distance from itself node is will be 0, correct? And then what we will do, we'll check the queue is not empty, queue is empty method, and if queue is not empty means we have to do like this, and then we will go to find its neighbor. To do that, what we have to do, we have to get a node. Let's see, this is a node, right? And this node is nothing but what, we have queue, this queue we have, and then we will remove, you can call poll method also, and we'll check this node is already visited or not, right? So for that, what we have to do, we have to calculate, we have to check this is visited or not, right? As well as we'll check the age we have given, adge, why it is not coming, right? This one, on age we will check this node, right? If doesn't have what, -1, right? If doesn't have -1, and what we will check, and the distance that we have doesn't contains what, this age, right? Distance at this node, right? Distance of this node is from here to this node, right? Equal to, if this is max value, right? Say we'll check the if it is maximum value that we have, integer dot max, that we have default value we have put, right? This one, if this is maximum value, see what we have taken, distance 1, distance 2 we have taken, and we have added default value. If this distance have default value this, right, the max value, in that case, and the age value should not have -1, means there is a real age that have the value, then we will do, first of all we should update the queue, we pass our ages, right? Here it should be age, and this ages we have to add, you can say, give here, we'll pass these edges, right? Now this is done, we have added on the queue. What we should do, we have to find the distance, right? So we were talking about this one, so we should take this here, and we have to update it, right? How we'll update this, we will do the distance that we have, right? Default values of the distance of this node, right? At this node, that itself that we are talking about, distance of itself, we have what default value have, that is 0, and then its children till the next neighbor we'll get +1, we have to do, like say we have 0 node and it is connected with what, let's suppose 2, right? And then it's connected with 3. So from 0 to itself is 0, but from 0 to 2 it will be 1, right? So we have to update. Now coming to the next, here I think this is done. Yeah, this is done. So we have calculated all the distances. So we'll update our each distances. So 2 times we will pass this distance, and this distances will get filled. Um, this one, and in this max value will get replaced, because we are checking if this is at max value, means we have not visited this one. We don't need to create one visited and we have to update, right? No need to do that, right? And this is uh, we can say method, right? Oh, sorry, I have given DFS. So this is not DFS, this is BFS. Sorry, BFS. I'll take in a small letter BFS. So we are taking BFS method, and that's why I'll DFS we have already done, right? So you can see on the first part of this video, in the we have seen the DFS. So in the BFS, what we have to do? First we will take the queue, and then we will add the first node. Then the first node, what is the distance of itself, that is 0. Then we'll come to the queue, right? We'll come to the queue. If queue is not empty, then what we will do, we'll uh, get remove poll. We'll call poll method or remove method. We'll remove from the queue first in, first out, right? And then what we will have, then we will check if is has not -1, means this is the real is, and as well as the default value that we have installed, that is max integer.max value at this node on the distance. If that is equal to max, means we have not visited this one, and you don't need to care about like it is visited or not. You can do it. We can make one visited if this is visited or not, and we can make true or false, but we don't need required. We have already filled the value, so we will check through this one, right? So if you want to do that, so you can take what, we will take a boolean, and then you will say visited node, and we'll do the default value. So that is not required, because we have one value already here, and we have already given the max integer value, right? So from there we can compare this one, see this is visited or not. Okay, next what we have queue. We have to add this node, right? Neighbor node, you can say. And this node is nothing but neighbor node. Okay, this node is nothing but our neighbor node. So you can say nei underscore neighbor, right? Let's see, we will pass, we are passing the edges, that's all, no problem, we can say. Now we are here, BFS utility we have, so we have both distances we have now filled, right? After this, how we'll get the node with the minimum value of appearance, right, of the distance, right? So how we'll do that? So that we will calculate here. Okay, so what we should do now, mm, we can create, we'll take one value, we can say, what we say, we'll take one integer, right? And that is nothing but our, let's see, this is our result. Okay, and we'll return this result later. Okay, we should take this one. No, we have to update. This time we should update actually. Let's say we'll take yeah, take result. We should take one result, we will take, and this is nothing but our max value. Okay, so let's see, integer dot max will put here max value we have. We will update this value. Another, we should take the minimum value, will take the distance, minimum distance, right? So this is nothing but mean node distance, right? Minimum distance, we can say mean distance node. Okay, mean distance node is minimum distance. We will take what, by default we'll take -1, let's suppose. Okay, then what we should do, we'll go for all its node, right? So I'll start with node, we'll say I equal to nothing but 0. This is the starting node, and we'll go to all its length. So I is what we have given is dot, we'll calculate length, and then I plus plus. Okay, now what we should do, we should check the if both have the, anyone have the max value, right? So if the distance that we have got, so we have distance 1, at distance 1 we will check value, right? So if this distance contain at I is integer dot max, that we have already integer, we'll take from here we have added this value, right? By default value we have added here. So we'll pass this one like this. Okay, if this is, we have what max value we have, right? So what we will do, we'll not do anything, we will continue. Okay, continue, let's suppose. Similarly we'll do for what another will take, and we'll say for distance 2. If that is have, then we'll continue. Okay, so what we will do, we will combine this one so that any one of the that we will get. So how we'll combine, we'll pass or, and we'll say this one. Okay, so either this or this, distance 1 and distance 2 have the default value that we have added, max value. If we have, means we don't need to do anything, right? We have not visited this one, right? We have not visited this one, right? So what we have to do, we will say we'll check onto the result. If we have the result is greater than what, we'll take a math function, math dot max, and we'll we'll pass two argument. The first argument should be we have this one. If we have not, if we have not this this not max value we have added here, and we have some value at here, right? Two thing, right? Two thing. If we don't have the max value at this distance 1 and distance 2, right? Then what we will do, we will update our value. So how we'll update its value? Let's suppose our value is let's suppose minimum distance we will update. So for each time minimum distance will be I, suppose I, if greater than this one, result is greater than this one, means we have. And then what we will do, we will update our result, right? So result will contain our max value, right? So that we can say this result is nothing but maximum distance. So let's suppose I'll update this so that you will not get confused. I'll say max value, max distance we'll say, and this is max distance we are updating each time. So we'll check with the max value, max distance from the node, right? How we'll get this? You know that we have the max of this one, correct? This. So each time you will get your value will get updated. Now we have our what distance. So after completing this, after completing this for loop, what we have to do, we should return our the minimum distance from the node. Let me compile this one. We are getting what distance from node 1 cannot be converted to array. Okay. Yes, what we have to do, we have to pass this array. We have to make this array. How I forget this one. Now we have line number 10. We had what we have as we are passing, then we are passing node, and then this one. So we have updated this one, right? Just you know, so we have to say this is our nothing but our array. Let me compile this one. This will work. So let me explain again what we have did here. Let's summarize this one. So we have taken two array from node 1 and from node 2, and we will put all the default value integer max value, and then we will do BFS and we'll update this max value, right? So let's see here in the BFS what we are doing here. We are from the starting node, we will update into the queue, we will add into the queue, then we will update its all itself value will be 0 from its starting node, and then we will update from each node, it will go to do plus, right? It one node to another node. Okay, another thing is what once we have our distance 1 distance 2 is filled, right? We'll check if that has will traverse for all the nodes, and we'll check if have node have maximum value of integer and distance at 2 both have maximum value, means we have not traversed this one, right? And so that we will calculate the max distance. If max distance will take default value is integer max, and we'll check with this one if which one is coming max. If get greater than this one, means we have to update our minimum, that is our I and itself, and then we have to do what, we'll update our max value. Okay, which one is coming max, that will update our max, right? So this will take a maximum value between the distances, and this will contain our minimum distance from one node to another node, right? Source to destination, you can say. So guys, I think you understood, right? If you have any doubt, please ping me in the comment box, I will help you there. And if you'll talk about the complexity, we are going from for all the nodes, right? So we can say for the BFS it will be O of n, and we are not taking extra space other than this queue, and this queue will store all the what we can say, we will store all its node, right? So O of 1 will be here, and we are taking two this one distances, right, of the same size. So O of n, O of n, and plus O of n, three distances, two distances, one q we are taking. So this, if we'll do the sum, we'll have O of n, right? So time complexity and space complexity will be O of n. Okay, thank you guys. Please hit comment, like, subscribe this video for more videos. Thank you so much.